In part E of exercise 1, we are asked to show that if U1 and U2 are strictly concave, then some of the earlier results also hold in the strict sense, that we have to show that U1 plus U2 is strictly concave as well, that some positive constant multiplied by U1 is strictly concave, and U1 composed with U2 is strictly concave, provided that U1 is strictly concave, is strictly increasing. So this is a good opportunity for us to more or less just repeat what we did earlier and really understand the definition of concavity. So recall that for strict concavity to hold, what we want is for this inequality to hold with a strict inequality. So let's get started. So U1 plus U2 is strictly concave, since for x and z in the domain of y, where x and z are different from each other, and we choose some arbitrary alpha in the units in the open unit interval, it holds for U1 and U2 respectively that we have these two inequalities. Alpha z greater than u and 1 minus alpha of u1 of x plus alpha u1 of z, and u2 of 1 minus alpha times x plus alpha of z is plus alpha times z is greater than 1 minus alpha times u2 of x plus alpha times u2 of z. And we'll note that if we just sum up on both sides of this strict inequality, we are done. So the sum of strictly concave functions is again strictly concave. And if we multiply by c on both sides of this inequality over here, then we have also shown this one. So the only thing we have left now is to show that this is strictly concave, provided that u1 of y is strictly increasing. Well, if we consider again the definition of strict concavity for u2, we have that this holds, so I'll just write down what we have above again. And then we recall that since u1 is strictly increasing, if you evaluate it in 2 points where one is strictly greater than the other, then the value of u1 in the strictly greater point is also strictly greater than the value of u1 in the smaller point, in the less great point. So this inequality definitely holds. Now we will use a strict concavity of u1 to write this out. Now note again that just because u2 is strictly concave, it doesn't mean that u2 of x is necessarily equal to u2 of z. For example, minus x squared is strictly concave, but you can still have two values, x and z, for which u2 could evaluate to the same value, in which case we would not be able to attain a strict inequality over here. So following along the same lines of thinking as earlier, we can show that strict inequality holds if u2 of x and u2 of z are different values. However, and equality would hold if these two evaluated to the same. So this is just a weak inequality. So actually note over here that it doesn't really matter whether U1 is strictly concave or not. We just know that if U2 is strictly concave and if U1 is strictly increasing and actually just concave would do, then U1 composed with U2 would be strictly concave. And that thing over here was, yeah, strictly concave. Good.